Hi everybody, welcome to my channel Programming in C with RSK. I am Rajendra Kulkarni. Today we are going to see how recursion works in C. Recursive functions we will be seeing through small programs. Let us go for the first program. So what is recursion? That we are going to see in this slide. A small program. Before that, what is C? What is recursion? When a function calls itself from within it, this calling method is called a recursion. Why recursion is used? That we will see in my next video. In this video, we will just see how recursion works. The program starts with declaration of a function, prototype declaration of function fun, which the function returns a int value, and to the function two int values are passed. Two values declared, two int variables declared and assigned with values 10 and 5. Then there is a function call. You can see the function prototype declaration, function call, everything is as usual, as normal as we have used up till now. Then there is a printf statement in the main. The value returned by the function fun is collected in a variable x, and the value of x is displayed by this printf statement. Then there is a function call, function definition. Function definition is also as the way we declare it normally, we define it normally. The first statement in this is a conditional check. If yy less than 0, return xx. Now what we are doing here is we are sending, or we are passing the values of a and b variables in the function call. In the function definition, variable xx and yy collect these values, and when the function starts execution, we check if yy is less than 0. In this call, we have passed b is equal to 5, so yy will contain 5. Naturally, it is not less than 0, and this return will not execute. It will be bypassed because the condition yy less than 0 is not getting evaluated to true. Then there is another step, I have called it step 1. Xx is equal to xx plus yy. So it is a simple addition of two variables which we have passed to the function, and xx variable is assigned with the new value as a result of addition of these two xx and yy variables. Then there is a simple printf statement which every time the function is called displays the values of xx and yy. Then yy is decremented, yy minus minus. So unless we modify the value of yy in such a way that it will approach 0 and reach 0, we cannot return from this function. If yy never becomes 0, what will happen? This function will go on calling itself and the program will crash. What happens is there is a memory segment called stack. On the stack, all the functions variables are stored. When function comes out of its execution, when the function returns, all the variables on the stack belonging to function or created by this function will die. In this case, in recursion, the function will not execute, will not return unless we give a condition where we force the function to return and stop the recursion or stop the iterations of the functions. That is why this yy is being modified in such a way that it will reach the value of 0, and in that case when the value of yy goes below 0, function will stop executing and it will return to the calling function. In this case it will return to the main. This is a crucial statement or crucial code which makes the function stop its recursion at the given value of yy. Then we call the function again. Look into from fun itself, we are calling fun, but with modified values of xx and yy, where yy is decremented in every function call. So after 5 calls, yy will become 0 and it will then become -1, and then only the function recursion will stop. If recursion doesn't stop, it goes on continuing, a stage will reach when the stack will start overflowing, because when the function is not returning, in every call the function will cause additional storage of the variables onto the stack, and since stack has a definite number of memory locations, it is not infinite, it is a finite number of memory locations available. A time will reach when the stack will overflow and the function and the program will terminate without giving any result. Now when I ran this program, this is the screenshot. You can see the values of yy and xs changing. Yy changes from 5 to 0, xs changes from 15 to 25, and this xs value 25 is returned to the main collected by x, variable x in the main, and displayed by the printf statement in the main. Now how this function works? First we make a call to the function from main. The function fun is called from main and passed with the variable values of 10 and 5. In the first iteration of the function execution, in the step 1, which we have marked here, xx will become 15, 10 plus 5, yy will be 4, and with these modified values of xx and yy, we call the function again from within the function. So now the function call will be fun 15, 4. In this call again xx will be 15 plus 4, yy will be yy minus 1 equal to 3, and with these modified values fun is called again from within itself, with fun having parameters 19 and 3 now, because xx and yy are being passed to the function from within itself. Again with this fun 19 and 3 variable as the parameters to be passed, next iteration takes place. The function calls itself again Now xx becomes 22, yy becomes 2, and with these modified values of xx and yy, we call the function with xs is equal to 22, sorry it is 12 written here, it should be 22, and yy will be 2. In this way, the function will go on executing, and a stage will come when yy is equal to 0, but since we have given a condition that when yy is less than 0 the function should return, so the last call to the function with xs being equal to 25 and yy being equal to 0 will cause xx is equal to 25 plus 0, yy will become minus 1. When we call again the function at step 3 in this iteration, what we are sending to the fun? 25 and minus 1 being the variable values we are passing to the fun, and when yy is less than 0, this if statement terms evaluates to true and causes function to return the value of xx to the main, where xx is where the variable x of the main collect this value and it gets displayed by this printf statement. In this way recursion works. Let us see one more program which will clarify in a better way, in a more, we will give more clarification to us. Now in this program I declared 2 underscore binary as a function. This is the prototype, int 2 underscore binary and int being the data type of the variable we are going to pass to this function. In main we have declared num as one int variable, then we prompt user to enter any number. Whatever number is entered by the user is assigned to variable num, and with this num we call the function where we collect the return value by the function into another variable belonging to main, int a. So what we are doing this call? Int a is equal to 2 underscore binary num. This is a normal call. In the function definition, again there is a if check, condition check. Now this time it is the condition of num being checked, which is passed to a. So if a is less than 1, this function will return. It will return the value of a to main. Then there is a printf statement %d a mod 2. What we are doing with this printf statement? The a mod 2 will cause to print or to display the value of the remainder of this a mod 2 expression. Then we divide a by 2 and again send that value of a to binary function, and again the 2 binary function returns the value to a. So in this way what is happening? A is consecutively being divided by 2 and also the modular division is taking place, and the result of modular definition, modular division is being displayed by the printf statement. So in effect, what this function is doing is, it is converting a decimal number into a binary equivalent of it, and it is being displayed on the screen by the printf successive execution of printf statement in the function, where printf is being where the a mod 2 expression, its evaluation or the value evaluated by a mod 2 is being displayed. In the first, when I worked this function, when I executed this program, I first entered 255 as my number, and this 255 is now converted into a binary number and displayed on the screen. The displayed binary number has its MSD to the right and LSD to the left. Actually, when we call this, when we convert the decimal number to binary number, the first evaluation of the a mod 2 is printed to the left. When it looks like it is the most significant digit of the binary number converted to from conversion to decimal number. However, this method of evaluating the binary number from a decimal number gives us least significant digit in the first iteration and most significant digit in the last iteration. So in case of 255, it doesn't make much of a difference because all are ones. When I executed this function with some different number, we will see the result. Conversion to binary is carried out by dividing the decimal number in variable a by 2 till a becomes less than 1. This is achieved by making recursive calls till a's value is less than 1. So in this call, we are sending or we are passing the value of a, which is a modified value, which is a result of evaluation of expression a by 2. So in every iteration, the number a which was sent from which was passed from the function call is being divided by 2, and it is again being sent or again being passed to the function as a parameter, and that function is modifying a again and assigning its value to a. Now in this second execution of this program, I entered the number 1, 2, 3, 4, 5, which got converted into a binary number and being displayed on the screen. MSB is to the right. The rightmost digit represents the most significant digit, and the leftmost digit represents the least significant digit. In this way, we convert a decimal number to binary number. How it gets converted? It is a simple explanation. First, the decimal number is 1, 2, 3, 4, 5. It is divided by 2 and the remainder is 1. Next, the result of execution of this division by 2 is again divided by 2 and the remainder is displayed on the screen. In this fashion, in every iteration or in every function recursive call to the function, number 1, 2, 3, 4, 5 gets converted into the binary number equivalent to it, and it gets till the division goes on till the number to which we want to convert to the binary number is reduced to 1. So in this way, how the conversion of decimal to binary number works, and in this way how the recursion works. More theory and explanation on recursion I will be creating or making a new video, and that video I will post in the future. Till then, what we have seen is how recursion works.